Welcome back learners in our channel Learn Easy Assam. Today in our video lesson we are going to discuss about ray optics and optical instruments, and there we will discuss about refraction at spherical surfaces and lenses. So let's start. We have already discussed about all these topics here, you can see in the screen, and if you have not yet seen all these videos or previous videos, then you can go and check them out. And if you have not yet subscribed this channel, you can subscribe this channel so that you will get all the videos one by one in details and in organized manner. So let's start refraction at spherical surfaces and by lenses. Let us consider here, we can consider a spherical surface. This is the spherical surface, and this blue color we can consider this as some other medium. So this is suppose medium 2 and with refractive index n2. And this black color area we can consider as medium 1 with refractive index n1, and we can see here this curved surface called this as spherical surface. So if you want to see the behavior of reflection and refraction, then we have to have some object. So let us see that there is an object here. Suppose this is the object, and what will happen, light will go and fall on the curved surface in this manner. Then at this point we have to draw a normal. So at this point we can draw a normal here in this way. So this is the normal, and we know that if it is a spherical surface, then the normal will intersect at the principal axis. This dotted line is the principal axis, and at the point of intersection, this point of intersection we called it as center of curvature C. We can write here C. And this light ray, after falling on the curved surface, it will go inside the medium 2, that is there will be refraction. So it will come towards the normal. Since it is the denser medium, we have considered n2, this blue color area as denser medium, blue color medium as denser medium. So it will bend towards the normal in this way. Suppose it is bending towards the normal. Now we can say that this is the object O, and we can say this is a ray which will contribute for the formation of image. So we can write here I. And again we can draw the line like this, and this is suppose P, and this is nothing, suppose N. Then what we can write here, this is N. Okay, and if we draw a perpendicular here, what will happen, this will be like this, and suppose this is M. And now we can see the object distance, image distance, and the radius of curvature. So if you see here, this is the object distance, this is O, object distance here. So from O to this M, we can consider it as the object distance U, since this is object. Then from M to I, we can consider this is as image distance V, and from M to C, we can consider this is as the radius of curvature R. So we have got all these things. So in order to find the relation for spherical surface, refraction at spherical surface, we need to find the angle of incidence, okay, then angle of refraction R, that is small r, and we have to use Snell's law so that we will get the final relation. So first our work is to find the angle of incidence and angle of refraction. So this is the angle of incidence, we can see here, this is the angle of incidence, and this is angle of refraction. So we have to consider first the triangle NOM. Suppose this is N, this is O, and this is M. We already know, we have seen this diagram. So from this diagram we can say that this is the triangle. So if you consider this triangle, and if you consider tan of this triangle, tan of this angle, NOM is the angle here now. So if you consider tan, before doing all this thing, let us first we have to assume something. That first assumption is that the aperture of the surface is small as compared to other distances involved. So aperture is small. That means if the surface, if you can see in cameras, you will see that in cameras there is a hole which controls the amount of light entering inside the camera. That hole is called the aperture. That hole sometimes become smaller and sometimes it become bigger. So depending on the amount of light required for the photo shot, the hole will adjust its size, and that size is nothing but it is the aperture. So here we have considered that the aperture of the surface is small as compared to other distances. So if this is the lens, then we have considered the aperture as very small as compared to the other distance. Other distance means if it may be the object distance, the image distance, and the image height, object height, and so on. So we have considered this in this way. So, and the second assumption, we can see that the length NP, we can see here this is NP. This is NP is considered to be nearly perpendicular to the principal axis. That means it is NM. So we can say NP is nearly equal to NM. These are two assumptions before finding any relation or refraction at spherical surface. Now we will consider tan of the angle. You can see here NOM. So this triangle is there, NOM. So we have to consider this angle, then we will get tan of the angle NOM. What it will be, you can see NOM, tan of angle NOM. So we know tan theta is nothing but perpendicular by base. So P by B, you can say. So perpendicular by base. So we can write here this is the perpendicular, this is MN is the perpendicular here. So MN by, and the base is nothing but it is OM. This is OM. Then another triangle we have to consider tan NIM. So NIM, we are considering tan NIM. N is this, I is this, M is this. So the perpendicular will remain same, that is M N, and the base will be different. This is the image distance, I think that is MI. So you can write here MI. And another 10, that 10 will be NCM. So if you write NCM, then the perpendicular will remain same, MN, divided by the base. Base is nothing but CM, that is MC. You can write here MC. So you can see here that if you see carefully, then you will know that these 10 relations having some common terms, that is MN. MN is the common perpendicular for all the triangles, and all the triangles involve this U, V, and R. So we want to find a relation between object distance, image distance, and the radius of curvature. So we have to consider these triangles in this way. Now we have to again assume that for a small angle, we know that for small angles, we know that tan theta is nearly equal to theta. That assumption we know. So that we can write here now. Let us see what we can write. Now NOM is directly, we can write is equal to MN by OM. Then NIM we can directly write from this principle. Okay, from this assumption we can write this. NIM will be MN by MI, and NCM is nothing but MN by MC. From this assumption we can cut out the 10 part, and we can write all these things. Now you see, now what we have to do, we have to find the angle of incidence and angle of reflection. Now it will be very easy to find it out. So for triangle, we can see for triangle NOC, what is NOC here? Let's see, N is this, O is this, and C is this. So this triangle, so we have to consider this triangle NOC. What is I? I is the exterior angle. So I is the exterior angle. So we have to recall the properties of exterior angle. So if this is a triangle, okay, and if this is the exterior angle, suppose this is the exterior angle, here it is I, and if we consider this angle as one angle and this as angle 2, then we can write that from the property of exterior angle, I is nothing but angle 1 plus angle 2, angle 1 plus angle 2. So here you see what is angle 1. Here you can see that angle 1 is nothing from this triangle. you can write that angle I is equal to this triangle, that is angle NOM. So this is this triangle angle NOM plus angle NCM. We can write NCM. So this triangle. So we have already have the relation of NOM and NCM from here. This is NOM and this is NCM. So you can directly write the ratios. That is MN by OM plus MN by MC. Suppose this is equation number 1. Now let us consider the other triangle. Other triangle we have considered, suppose for the triangle NIC. So NIC is what we can see here, NIC. This is the triangle. So if we consider the exterior angle, this NCM, this is NCM, this is the exterior angle. Okay, so let us recall the property of this. So this is the triangle here in this way, and this is NI and this is C. This is the angle of refraction. We are going to find this angle, and if you consider this is the exterior angle, this one is the exterior angle. So from exterior angle property we can write that angle R is equal to angle NCM. So you have to see that NCM, this NCM is the exterior angle, okay, minus angle NIM. So this is the property of exterior angle. NIM is NIM. So this angle minus this angle will give you this internal R angle. So NCM we already got, that is MN by MC, minus NIM we already got, that is MN, this is MN by MI. So we have got I and R, which are very important relations. This is I we have got and this is R we have got. So we have got I and R. So what we have to use? We have to use now we have to use Snell's law. So that we will connect I and R. So let us use the Snell's law. So we can write directly that by Snell's law. So if you can remember Snell's law, what happens if there is a medium here with effective index N2 and there is a medium effective index N1, then we can write that effective index N1 into sine of the incident angle. The sine of the incident angle, if the light is falling in this way, so if this is the angle of incidence I, then we can write sine of the incident angle I must be equal to the refractive index in the second medium multiplied by sine of the angle of reflection at the second medium. So this is the angle of reflection at the second medium. This is the relation. And for small angles we can write, since we all know that the for small angles sine theta also equal to theta. So we can write N1I is equal to N2R, and we have already got I and R from the previous calculation, that this is I, this is I, this one is I, so this part we have to write, and this one is R, so this part we have to write. So if you write this, then we can write here Ni into I, that will be what, Mn by Om plus Mn by Mc. Okay, that is equal to N2 is here, we can write N2, and R is nothing. If you can see here again, R is Mn by Mc minus Mn by Mi. So we have to write here R, that is mn by mc minus mn by mi. So this is the relation. Here you can see this mn, everywhere mn is common, so we can cancel it out. Mn, everywhere there is mn, so we can cancel it out. So what we will get? We will get n1 by 1 by om plus 1 by mc plus n2, this is n2, this should be n2 by 1 by mc by minus 1 by mi. So this we can write as n1 by om plus n2 by mi. If we rearrange it, we can write it. So n1 by om plus n2 by mi. Okay, and that is equal to this negative sign will be there, n1 n2 minus, here we have to move this 1 by mc to right hand side, then it will become minus, and we can write here n2 minus n1 by mc. So this is the important relation. So we have not used here sign convention. If we use sign convention, then we will get the original equation. So this is our final equation actually. So from this equation we can easily find out the relation between u, v and r. If we use the sign convention, then what will happen? We can write this as om. Om will be what? Om is the object distance. So if you see the diagram, this object distance om is from right hand side to left hand side, so it is negative. This negative, so om is nothing but minus u. Then mi is the image distance which is from left hand side to right hand side, so it should be positive. Then again mc is also from left hand side to right hand side, so it should be positive. So if we put all these things, then what we will get from this, we can write it again here, that n1 by v minus n2 by u is equal to n2 minus n1 by r. So this is the final equation using sign convention. So I hope you have understood this derivation, which is very important actually, so that we can derive other length formulas from this. So if let us revise it again. So what we have to do, we have to first keep in mind that we have to find the angle of incidence and angle of refraction. So from this diagram, we have to draw this diagram. Then from this diagram we can easily derive the formula. First we have to consider the tan of some triangles. So those are those triangles which involve object distance, image distance and the radius of curvature. So we have to write here tan of angle NOM, tan of triangle NIM and NCM. From this we have got some relation from tan theta property. Then after that we have to consider, we have to cut out all the tan. So then we have to use the assumption that for a small angle tan theta is equal to theta, so that we can write directly the angle and the ratios. You can write directly angle equal to the ratios. So we have got all these things. Now we have to use the property of interior angle and exterior angle. From that we can get angle I and angle R. After getting angle I and angle R, we can use this I and R in Snell's law. So if you are using it in Snell's law, then again we have to do some assumption, that is sin theta is nearly equal to theta, so that sin will get cancelled out and it will remain that n1i is equal to n2r. This is the our working formula. From this we can find the relation. So after putting I and R, we will have to do some arrangement and we will get this equation, this relation or this equation. And after getting this equation, we can again use sign convention and we will find the final equation which you can use directly for mathematical calculation. So this is our equation. So hope you have understood reflection at spherical surface, and in our next video we are going to discuss about the second part, that is the thin lens formula. So in our next video we are going to use this relation what we have discussed today with spherical surfaces, and we are going to use to find the thin lens formula in our next video. So hope you have liked this video, you have understood the concept, and if you have not subscribed yet, I request you to subscribe and click the bell icon so that you will get all the videos one by one for the whole chapter and for the whole physics book. Thank you for watching.